Thank you very much. All right, so everybody's awake and energized for the next section. And I think we're going to start our next panel. It's going to be led up by Gail Breaker.
Okay, if the panelists have a seat.
This is to advance the slides.
Thank you.
The one on the right. Yep.
Okay, so we're starting off with looking at some of the fundamental issues behind health issues and some of the tools that we might have for material selection. We all agreed that we were going to be very brief in introducing our panelists today. You have in your agenda their names and titles, and so they're here for you today. They're here in the order in which we're going to be presenting. So Charlene Bayer, you already met. Christopher Weis with the National Institute of Environmental Health Sciences, Meg Schwarzman with the Center for Green Chemistry, Ashley White, who's a senior research fellow at USGBC, and Russell Perry with the Smith Group. And so I'm going to start us off with Charlene, if you could come on up.
Good morning one more time. Let me figure out. I don't know how to change. How do I change?
Right
This
button on that.
This one. Okay. So going quickly, we're going to talk about the fundamentals of exposure. First, how do we get exposed? We get exposed from a lot of ways, and one of the things the building community does not always think about is all of these other directions of exposure. The workers are exposed during manufacture, during extraction. That exposure carries on to the production of the material. Then the people that use the material have exposures, but we also have exposures from the waste from the factory that goes into the landfills, goes into the water, goes into a variety of things. The excess from the goods does the same thing. We have exposure from the agriculture. We have exposure that leads to the exposures from the food. So we're getting hit from a variety of parameters, both environmentally and as humans. And one of the things I've learned to think about as during my time as a fellow that is unique to, I think, what many people in this room and many of the HRBR people think of is we have to think of the entire life cycle. We can't just think of what's going on in the building itself, but many of the people that are concerned with the green chemistry are not looking at the exposures in the building, and they are different. We all know about volatile organic compounds. I've been in this arena since the early 1980s, and volatile organic compounds have been the compounds we've cared about the most. We've got the most research on, and primarily they're the easiest. They are easy to, in comparison to the other compounds, they're very easy to measure. Not that any air is that easy, but they are easy. And so we all understand that, but what we have learned over the years is that basically in every room, for most of the time, you're exposed to the same compounds all the time. We don't have sick building syndrome in every room we go into. We know that we can eliminate a lot of these by just not bringing those materials in, but we still have exposures. What's going on? We have the SVOCs, the semi-volatile organic compounds, which we are learning for long-term chronic health are much more dangerous. Those are the things like the phthalates, the pesticides, the flame retardants, et cetera, that we're exposed to. I've got the boiling points listed, which is how they're defined by the World Health Organization. Very recently, literally within the last year, the very volatile organic compounds are coming into play. These are almost even harder to measure because they're so volatile. They're very difficult for us to trap to even be able to identify them. These are things like propane and other very volatile organic compounds. So as a result, it's this mixture that's important. Now, a lot of these are coming off the materials as we're sitting in this room right now. I don't want to be the harbinger of doom, but sometimes I feel like it. But that gives you an idea of the things that are coming on. But the idea of the materials transparency movement is to let you know what these are and to see whether we can't substitute them for safer compounds. So, what endpoints are appropriate across all life stages? This is really important for the building industry to understand. What are the differences between a hazard and a risk? And there'll be more discussions on this, and I hope this is one of the topics we talk about. A hazard is anything that we know causes harm. A risk is what is your chance that you're going to be harmed by this hazard? The dose makes the poison. We hear this all the time. Risk is very important in the indoor environment occupational stages. So what's the difference? If we have a flame retardant, in a building, if a fire is a real hazard. It will cause harm or has a high potential of causing harm. So we use flame retardants in place. But flame retardants have other issues, especially when we look at end of life and manufacture. And they can be an issue in the occupational phase. But which is worse? If we take the flame retardant and we fully enclose it in a wall, we have cut back on the hazard during the occupational phase. But if the flame retardant is in the fabric on the sofa you're sitting on or on the chairs you're sitting on right now, it is a hazard and a risk because you are exposed right now to what's coming off of that, not just when it's end of life. Okay, so that's a really simple way to look at hazard and risk. And I can see Ken doesn't like what I'm saying, so he's going to talk about this in a while. But this is an easy way to look at it. But one of the things you have to look at when it's enclosed in the wall is what if you develop an air pathway? What if you have a flood? Now you're getting exposures. I was getting there. Okay, something else you have to think about is the reactions that are going on inside. Many of us understand indoor air chemistry. That's where something is in the room. You think you know what is being given off, such as limonene, which is your lemon scent in your cleaners, etc. But the ozone levels that are in this room, and I mean just the levels that are in this room, 25% of the outdoor ozone penetrates the building shell without falling apart. It converts it to things like formaldehyde and other products. So we have manufacturers, the carpet manufacturers years ago got formaldehyde out of their products, but if you take and you measure it in a room, you can still measure formaldehyde coming out. That's a combination of sink effect where they've absorbed everything that's around them, but also the exposure from ozone that has converted into giving off formaldehyde. So this is an issue for manufacturers. They didn't put it in there. What do? And one of the big things which I want to talk about a lot today is emissions versus avoidance lists. We have been doing emission testing for a long time. You know about Green Guard, most of the programs in Europe, and all are measuring emissions. It's not the same as the red list where we're trying to just get the chemicals out of there. The emissions have things to do with what's coming off of the product during use. What's coming off as the product absorbs compounds, etc. How do we link these together? It's a very difficult problem, and I'm not sure how we do it, but we need to understand it, particularly as regulations come out for emissions, and then transparency programs are coming out for red lists. So, each of us were asked to do one big question, and we'll talk about these later. This leads into my big question, which we will use as the panel as we go on.